Okay, we're going to start by reviewing translations and stretches to our graphs. Now, I'm not talking for translations, translating this from an English situation to a Spanish or French. I'm talking about sliding a graph sideways or up and down. That's what I mean by translations. So here I have my original x squared, which you know is a parabola. If I put a plus 2 after that, all that's going to do is just move my graph 2 units up. If I have a minus 2 after the squared, that's going to just move my original graph 2 units down. However, if I have a plus 2 hanging out with the x on the inside here, before I do the squaring, since it's hanging out with the x then, it's going to move it in the x direction, which is left and right. So you got to think, okay, I have an x squared here. What would cause this squared part to be 0? And you know that that's 0. So you think of it this way here. What would cause that to be 0? And that's a negative 2. So in other words, it's going to move it 2 units to the left. Some people want to think of it as that what I just talked about here. Or some people want to think about it as it's always the opposite of what's going on with the x. So if you think of what would cause this here to be 0, that would be a positive 2 when this was originally a 0 here on the inside to cause that to be 0. So it moves everything 2 units to the right. Or you can think of it as going the opposite of what's hanging out with the x. If I put a number in front of my squared, I'm still going to have my original parabola, and then it's going to go ahead and multiply everything by 2. In other words, it's going to be a vertical stretch of 2. Here I'm still going to have my original parabola, but now it's going to take all those outputs, the y values, and take half of them, so it's going to be a vertical stretch of a half. Once again, I'm on the inside here. When it's hanging out with the x, just like up here, kind of does the opposite of what you would think. Here with a plus 2, you'd often think going 2 to the right when it's really 2 to the left. Here we're timesing by 2. Most people think it would be doubled, but it's really the opposite of that, so it's going to be a vertical or a horizontal stretch of a half. We know it's horizontal because we're hanging out with the x. Just like up here, we were hanging out with the x, so it's a horizontal. These were hanging out after the squared, so they were all vertical. Vertical translation of 2 up, vertical translation of 2 down, vertical stretch of a half, vertical stretch of 2. So if it's hanging out after the squared or after you apply your function, it's always vertical. If it's hanging out before you do anything with your function, it's always horizontal, which is left and right. So here, it's going to be the hanging out with the x. It's going to be the opposite of that. So instead of being half as tall, it's going to then be twice as tall. So, thinking of this right here, we have our parabola. What would a plus 2 do to this graph? Well, that plus 2 is hanging out with the x's, so that means we're going to move everything in the horizontal direction. And remember, hanging out with the x's is always the opposite of what you would think, so it's going to be 2 units to the left. So it's going to take this red graph, move everything 2 units to the left. Here we have our function. It says if we take our function and we just subtract 3, what's that going to do to our graph? It's going to take our parabola right here, and since the minus 3 is hanging out outside of the function, after the function, it's going to move it up and down, so it's going to move it 3 units down. Here we have our function, and we have a 2 hanging out outside of our function after we have applied our function. So in other words, that's going to affect the vertical, just like this one here, because it was hanging out after our function. And it's going to then make it twice as tall. So in other words, all you'd have to do is come along and just double all your y values. So this point here would be still at 2, 0, because you double your y value of 0, you get 0. Here you have 1, 1, but you got to double your y value, takes you up here. Here you have a point 3, 1, you got to double the y value, it would take you here. This point here was 4, 4, but you'd have to double your y value, and it would take you up to 4, 8. Here we have something hanging out with the x, so we know that's going to be kind of the opposite of what we would initially be thinking, and it would be horizontal. So when you have a half of an x, that's going to make it twice as wide. Well, if it's twice as wide, that's a horizontal stretch of 2, which means you have to go ahead and double all your x values. So here, this point is 0, 4. You double your x value, you still get 0. Here, your point is 1, 1, but you double your x value of 1. Keep the same y value, it would put you over here. Here, you have your point 2, 4. You got to double your x value, it would put you over here. Here, all we're doing, since it's horizontal, is affecting the x's. We take our 3, 1 point right here. You'd have to double the x values, so it'd take you over to 6, still at a height of 1. And then you could draw in your new parabola going through these points. So suppose we have a situation like this. We have our given point. We have this stuff affecting our point. We put a 2 in front. We know that that's going to double the y value because it's a vertical stretch of 2. Here we have a plus 4. Well, we know that's also going to then move it 4 units up, which then affects the y value. So in this case, we're not doing anything to the x, but our y value is being doubled, and then it's being moved up 4. So we got to double the y value and then add 4. So in other words, we get the new point that this gets moved to after this right here is 3, 2. This is your greatest integer function. It says I don't care what you put in, you always round it down to the next largest integer. So if you get like a 2.5, you round it down to a 2. If you get a 2.9, you round it down to a 2. A 2.999, you always round it down to 2. But once you get up to like a 3 or a 3.1, it's going to round it down to just 3. If you wanted to graph it, this would be your calculator notation. The INT is underneath your math button. But what I want to look at is how would this graph differ compared to the original? Well, as we look here, this 2 is in front of this, which means it would be a vertical stretch of 2. When we're looking at this here, that minus 3 is hanging out with the x, so that's got to be a horizontal thing because it's hanging out with x, and x is horizontal. And it's always the opposite of what we think, so it's going to be 3 units to the right. This is hanging out after our function, so that means it's going to affect the y value and move it up 1.